Number 1. Simplify each expression. What we have to do is factor this. Are there factors of 15 that equal 8? 5 and 3. So this is the same as x plus 3, x plus 5. Are there factors of 18 that equal 9? 6 and 3. Yes. Yes. Welcome. All right, question. Can I cancel anything out? That is your answer right there. That's the answer. But if you look...
Factors of 18 that also equal 9.
Yes. But it wants to know what are the restrictions. Only put the restrictions if it asks tomorrow, okay? So what am I not allowed to have in the denominator? What are the values of the restricted from the domain? So this one is actually asking for the restrictions. So what would make this be 0? And what would make that be 0? That's your final answer for 1.
I was like, wait, is this from
Alright, the bottom, what would give me a 0 in the denominator?
Wait, I have a question.
Yes.
Why is it negative 3 if the 3's cancel out?
Because it's still there to begin with. You'll find out next week when we graph this, it puts a hole in the graph.
Okay.
Because in its current state, it would produce a 0 in the denominator, which is against the law. That we're not allowed to have 0 in the denominator. So what would make that be 0 in the denominator is if x equaled negative 3. And for that one, if it's negative 6. Even if it cancels out, you're still not allowed to have it. Because you're not allowed to have 0 in the denominator.
I know, but it's just not the answer, so I understand you said that it doesn't matter.
Yeah. So, trust me right now, Jackson, and I'll explain it next week a little bit better. Why, even though it cancels out. When we graph it, it'll make more sense. Because our graph will have a hole there. So, all right, number 2. Will the bottom factor? Are there factors of negative 30 that equal 1? 6 and 5, right? So this is going to factor into, the signs are different, the bigger one's positive. X plus 6, X minus 5. Before I even... I'm sorry, it's on bottom, yeah. All right, what would give me a 0 in the denominator? If that x right there equaled what? 0. So x cannot equal 0. How about that one right there? What would make that a 0? Perfect. And what would make that a 0? Okay. So before we go any further, what can I cancel out? I can cancel out the x minus 5s. Is there anything else?
Did we get the 0 from the x and from the x?
Yes. Well, we got it from the 0, from the x.
Still put the 5 even though we canceled it out?
Yes. That's what Jackson was just saying on the last problem. All right, how about that x and that x? Those cancel out. So now for my final answer, what is left on top? Yeah. What's left on the bottom? I didn't get rid of the 3. The 3 is still there. The x is canceled out. If I have an x on the bottom and top by itself, I can cancel it out. You're not being annoying. Because there's an x by itself right there, correct? If that x right there equaled 0, it would make the entire thing 0, which is against the law. Good. No, that's a good question, Jackson. I don't mind that.
If a number has a variable by it and it's not in the parentheses, it just cancels.
No, the number's still there. It didn't cancel.
No,
The x is cancels, yes.
Yeah.
No, look, you can leave it like that. Or...
Wait, well, Let's make it more convenient.
Either one's fine. I would just leave it, but if you wanted. All right, moving on. Number 3. There are several ways to do number 3.
Let's do the easiest.
Well, the easiest way would probably be to cross cancel the numbers before you did anything. So 7 goes into 7 once, 7 goes into 42 6 times. 5 goes into 5 once, 5 goes into 15 3 times. We can. So if I have 2 x's on top and 3 on the bottom, I can get rid of the 2 on top and get rid of 2 on the bottom. So if I have 3 and I get rid of 2, how many are left? 1. So now what is left? I have 6 over 3. Can I reduce that? So 3 goes into 3 once, 3 goes into 6 twice. So 2 goes on top. What variable do I have? Over what's left on the bottom? X. That's your final answer. I don't care about what's restricted in the domain on this problem.
How do you know?
Are you going?
No, I did tutoring yesterday. Yes. All right, Kate, I'm going to show you another way of doing this problem, okay?
Okay.
Yep. I'm going to show you a different way. It might be easier for you. I don't know. So if I have 42x squared over 15 times 5y squared over 7x cubed. I said cubed. Why'd you write squared? There we go. Another way you could have done this might be easier for you, it still gets the correct answer, is multiply straight across. 42 times 5. 42 times 5 is 210. X squared, y squared. Over 15 times 7, which is 105. And the only thing I have on the bottom is an x cubed. What's the number that goes into 210 and 105? 5 will. So let's do 210 divided by 5. And I get 42. Let's do 105 divided by 5. It should be 21. And it is. Is there a number that goes into 42 and 21? Okay. 3 goes into that 7. 3 goes into that 14. Is there a number that goes into 14 and 7? 7 goes into 7 once. 7 goes into 14 twice. So that means I have a 2 left over. We have x squared divided by x cubed. When you divide, you subtract. 2 minus 3 is negative 1. We're not allowed negative exponents, so to get rid of it, we put it on the bottom of our fraction. And then, what is left with the y's? There you go. I don't know what's more complicated for your brain, but I think we got the same answer doing it both ways. So whatever is easier for you, it doesn't matter.
2y squared over x.
Yes.
That makes sense.
And if you look on here, I got 2y squared over x as well. Whatever works for your brain, do it. Do that. All right, number 4 is a division problem. So we have to keep it, change it, flip it. So I'm going to do 15 a squared b squared over 21ab cubed times, and now I swap it, 5a cubed b squared over 6ab cubed. Once again, you can either cancel first, you can cancel now, or you can multiply straight across. It really doesn't matter. All right, I'm just going to multiply straight across right now because I think that's the way I taught it to you. 15 times 5 is 75. we had to keep it, change it, flip it. So we did the reciprocal of our second term.
Is there a way we could do the same as we did the last time? Like 6 goes into 6?
Yep, you can do it like that. All right, 21 times 6 is 126. A squared times a cubed is a to the 5th. B squared times b squared is b to the 4th. That's the top of our fraction. The bottom, a times a is a squared. B cubed times b cubed is b to the 6th. So if you make it at least that far, I'll give you half credit for that. But now we need a number that goes into 75 and 126. 2 doesn't go into 75 evenly, does it? Does 3? How do I know? Because I add them up, right? 7 and 5 is 12. 3 goes into 12. 1 and 2 is 3. 3 and 6 is 9. 3 goes into that. So 3 goes into 75 25 times. 3 goes into 126 42 times. So 25 over 42 will not reduce. All right, I have an a to the 5th and an a squared. What's 5 minus 2? Is that positive? So it's going to go on top. So I'm just going to go over here and put my answer 25 over 42. 5 minus 2 is 3. So that goes on top. 4 minus 6 is negative 2. It's negative, so it goes on the bottom. That's your final answer. Yes. All right, number 5. Also, when we're done with this, I'm going to put some homework problems from yesterday up on the board too that were pretty challenging. All right, we are multiplying. So what we're doing here is I'm going to factor both of these. Are there factors of negative 4 that equal 3? Yes, 4 and 1, correct? Signs are different. The bigger one has to be positive. So x plus 4, x minus 1. Are there factors of 16 that equal 0? 4 and 4. X plus 4, x minus 4. So this x minus 4 cancels out with this x minus 4. This x plus 4 cancels out with x plus 4. It doesn't matter which one you cancel out, but you can only cancel one of them. All right, so what is left? X plus 4, x minus 1, all over x minus 7. That is your final answer. Nope. And I don't even want to know the restrictions.
How do you know when to stop? Some of them go so far.
Because this one we're just multiplying. See, on these bottom two, we're actually solving for x, and it'll say that on the test tomorrow. It'll say solve, so then you'll know what to do on that one. All right, let's move on. So this one we're dividing. So before we do anything, let's just go ahead and flip it now or switch it. So x squared plus 9x plus 18 over x plus 4 times x plus 4. Yeah, that says 9x right there. And now I need to flip this. So I'm going to put x squared plus 2x minus 8 over 2 minus x. So that will get you partial credit just doing that. Keep it, change it, flip it.
If you had x plus 4 on the numerator of the other side, would you take both the x plus 4 side or just
Yeah. Well, You can only take out one of them, so if I had another x plus 4 somewhere, I could take it out, but you can only take out one. All right, from here, are there factors of 18 that equal 9? X plus 3, x plus 6. Are there factors of negative 8 that equal 2? 2 and 4, yes. So signs are different. The bigger one's positive. So x plus 4 and x minus 2. This is where the book hates us and tries to make our life miserable. Is that in standard form? So I personally would write it in standard form, negative x plus 2, and then I would pull out a negative. And then it's going to give you x minus 2. That's a little confusing. I'm not going to lie about that. I'll probably get rid, if there's a problem like that on the test, I'll probably get rid of it because I'm getting rid of 2 questions. You're only going to have 8 questions on there, not 10. Yep. So now cancel out what you can. I have an x plus 4 and an x plus 4. Is that it? Is that all I can cancel out?
Was that a negative x plus 2?
Well, the negative was in front. Parentheses x minus 2. I'll get there. Slow your roll, Jackson. You're too advanced right now. All right, so what was left on the top? X plus 3, x plus 6. And what is left on the bottom? The negative x plus 4. So Jackson, I would just put it right there. That would make the most sense to me. Just put it right there. And if you want, you can... I'm sorry, what? We canceled out that x plus 4 and that x plus 4. Not both of them, only one of them.
Why is there a negative?
Because if you look, we factored out a negative here to get an x minus 2 so we could cancel that out. And it didn't magically disappear. I would, yeah. Does anyone want pizza bread?
It's $3. You take cash and cash out.
Audrey does. Or are you just waiting? Yes.
Not have a negative on the bottom. You got those on the top.
It doesn't matter. The negative can be on the bottom, it can be on the top, or it can be out front. It doesn't matter. All right, moving on. Number 7 we are adding, correct? So we need, in order to add, we need common. So will the denominator of 7 factor? Will x squared minus 9 factor? Is it a perfect square? Is that a perfect square? And is that a negative? So it'll factor. X plus 3, x minus 3. All right, are there factors of 21 that equal 10? So Audrey, there's a rumor going around that the pizza bread was made with expired milk. Is that true or no? Okay. All right, thank you. That's all.
That's just nice for us. It's not just for others. We don't have baby sauce like that.
Okay. Okay. Thank you. All right. So if I'm not here tomorrow because I eat the pizza bread and get sick, your test will be so hard.
I won't bother myself so.
All right. So we need factors of 21 that equal 10. 3 and 7. Yes. Very good. So now we need a common denominator in order to add, correct? I have an x plus 3 and an x plus 3. I have an x minus 3. What's missing from here? X minus 3. So I need to add an x minus 3 over here. If I add it to the bottom, I must add it to the... All right, so I have an x minus 3 and x plus 3. What's missing from the left side?
7.
X plus 7. So if I add it to the bottom, I must add it to the top. So now, what is 5 times x? What's 5 times 7? What's 2 times x? 2 times negative 3? Okay, so let's combine those on top. 5x plus 2x is, and 35 minus 6 is 29. And we just said that our denominator is going to be x plus 3, x minus 3, and x plus 7.
Are we done?
With number 7, yes. Yes.
So you take the least common denominator.
Yep.
So why the x plus 7?
Because we had an x plus 7 over here, correct? So if I have one on the right, I must have one on the left. Because my least common denominator is going to be x plus 7, x plus 3, x minus 3.
Or that's like the whole
That is your most common denominator.
Where did the x minus 3 come from?
When we factored x squared minus 9. All right, let's go on to the next one. Isn't this fun? All right, well, x squared minus 5 factor into what? What is the perfect square of 5? It won't factor. No, that's fine. If it was 25, it would. All right. What will x squared plus 5x minus 14, will that factor? So that factors into x plus 7 and x minus 2. So we have an x plus 7. What's missing? All right, what do we have to do now? All right, I did that. What do we do now? I already have an x plus 7, so I don't need another one. Well, we are going to subtract, but what should I do with the numbers on top before we subtract? Multiply them. Yes, FOIL them. So now that's going to give us x times x is negative 2 times x is negative 2x. 3 times x is 3x. And 3 times negative 2 is negative 6. Will that simplify? Yes, it will. X squared plus x minus 6. And I'm going to put that in parentheses.
Is it the same order?
I just combined them. That's all. So that minus sign, what do I have to do with that minus sign now? It needs to be what to the second part? Okay. So negative times x squared is negative x squared. Negative times x is negative x. Negative times negative 6 is positive 6. So now I can finally bring down my x squared minus 5. And now we are going to combine like terms. Yes. It's right there. It's a subtraction problem, so that's right. So now what's x squared minus x squared? Okay. What is negative 5 plus 6? And the negative x is just there, right? And what was my denominator? You are correct. That is a legitimate math problem. Not the first semester we didn't. All right, 2 problems left, and we have 16 minutes. These are solving, so to solve them, what we do is we multiply the numerators by the least common denominator. So we need to figure out what our least common denominator is. Factors of 12 that equal 8. 2 times 6 is 12. 2 plus 6 is 8. So now I need to multiply each one of these 3 terms by the least common denominator. So I'm going to multiply this by y plus 2, y plus 6. Y plus 2, y plus 6, y plus 2, y plus 6. Once I do that, I'm going to cancel out as much as I can, and you should not have a numerator. You should not have a denominator left. Okay. Hold on.
Why are we adding y plus 2 and y plus 6 to every single one?
Because we're solving the equation, and in order to do so, we need to get rid of the denominator. So to get rid of our denominator, we multiply every single numerator by the least common denominator.
So like the ones up there.
This is different. That was just adding and subtracting. This is solving. That's the difference. That's a good question. I'm not even joking. That's a good question. Yes. Yep. All right. So now, if you look at the first term, I have a y plus 2 on the bottom and a y plus 2 on top. So that's gone. So what is left on the first term? 24.
Can I get rid of the y plus 6?
Eventually, we're not there yet. 24 times y plus 6. No, you cannot get rid of that y plus 6 on this in the first term.
Oh, okay, that's good.
So on the second one, we have a y plus 6. So I can get rid of the y plus 6. So minus 6 times y plus 2. And then on the last one, what happens to the y plus 2 and the y plus 6? They cancel out. So now we're going to do 24 times y, which is 24y. 24 times 6 is 144. Negative 6 times y is negative 6y. Negative 6 times 2 is negative 12. We're going to combine like terms. 24y minus 6y is 18y. 144 minus 12. 122, I think. Oh, 132, thank you. All right, so minus 132 minus 132. 18y equals negative 144. So negative 144 divided by 18 is negative 8. That is it. You just solve for y. That is a lot of work. You are correct.
So what?
All right, moving on. We have 12 minutes left. All right, my least common denominator, will n squared minus 4 factor? So that is my least common denominator, n plus 2, n minus 2. So I need to multiply the tops, the numerators of all 3 of those by that. So n plus 2, n minus 2. N plus 2, n minus 2, and n plus 2, n minus 2. So on the first term, I can factor, or I can get rid of the n plus 2 and the n plus 2. Wow, this problem's no joke.
Should you do the n plus 3 first? Because it's
I don't know what you're talking about. N plus 3, I don't see an N. Oh, right there?
like you put it in front.
Well, I need to multiply it by N minus 2. So that's it right there. And now we go on to the middle term. It's going to get rid of both of them, correct? And this one I can get rid of the N minus 2 and the N minus 2. So that leaves me...
You lost me.
Okay, hold on. Alright, where did I lose you? We canceled out the N plus 2, the N minus 2, and I crossed off the N plus 2, N minus 2, so that left me just the N. It's a minus N, so I wrote minus N. So on this one, I crossed off the N minus 2 and the N minus 2. There was an N already there, so N times N plus 2. It's a lot of N's. All right, so now I need to FOIL this. N times N is N squared, plus 3N, minus 2N, minus 6. The minus N is just kind of chilling. N times N is N squared. N times 2 is 2N. Oh, we're just getting warmed up. Combine like terms. N squared is the only N squared is right there. 3N minus 2N is N. But we have a minus N right here. So N minus N is 0. So it goes away. And then on the other side, we have N squared plus 2N.
So all the n's on the one side cancel.
Well, the 3N minus 2N is 1N, 1N minus 1N is 0. So yes, they cancel there. All right, so now what's N squared minus N squared? Nothing. So negative 6 equals 2N.
Oh, okay.
So divide by 2, divide by 2, N equals negative 3.
I retire.
On that note, we are done.
Yeah.